very beginning, it became very clear that to fight this power plant, we were going to have to try to find an expert. After calling all over across the country, I was able to find one that actually was very local. Right now, the list of credentials. He has a Bachelor of Science degree in nuclear engineering from Purdue University, a Master of Science degree in nuclear engineering from Northwestern University. Mr. Abboud worked for ComEd as a nuclear engineer after a period of research with Aragon National Laboratory. He served the U.S. Naval Reserve from 1981 to 1983. He also served in the U.S. Department of Energy. He served in the California Energy Commission Committee. He is currently the president and CEO at RGA Labs. So we actually have a real expert. So he will tell you about the power plant and after Abboud. Thank you.
Stephen, I'm also a former mayor. I've lived in McHenry County since 1967. I was a mayor over in Barrington Hills for 8 years, on the board for another 4. I appreciate those who have served. All the officials that are here, it's an interesting job. I will tell you that we were hired to look at this facility, and we were very clear that we were not going to come in as an objective. That if we were to look at it, we were to look at it as an objective analysis, and if the analysis indicated that there were no impacts and that it was good for the community, we did. And they agreed. However, after looking at it, and we took a very serious look at it, we found 13 different impacts of very much significance. I would not live next to this facility. I wouldn't want to have my family living next to this facility. And I was actually surprised that the developer, Venture in Northland, and they have some experience in building this facility. So my personal perspective as an engineer is that they should know that. I was surprised at the level of impact of this facility. It's a 435 megawatt facility, and to give you guys an idea of what that is, that's about 1/4 the size of a nuclear power station like Byron, Lakewood, Zion, which is now shut down. So this is a big facility. This is not, you've seen some of these small peaker plants around the area. There's one over in East ND. Those are substantially smaller than what this facility actually is. We did look at it, and let me just list off the communities that we found impacts to, and then I'll go through the impacts one by one to give you a quick idea of what each one of these things is. The impact radius is about out to 6 miles. That's a circumference. I'm sorry, radius on the circle. That's Oakwood Hills, Crystal Lake, Cary, Fort Barrington, Lakewood, Prairie Grove, Island Lake, Prairie Grove, Ridgefield, Bull Valley, McHenry, Lake in the Hills, Lakemoor, Wauconda, and associated areas of McHenry County and Lake County. And in the school district space, that includes districts 47, 155, 156, 118, 46, 3, 15, and 26. The report that we have is essentially complete. On a first level basis, we would like to get more information, both from the village and from Venture and Northland Power on some specifics of the design itself. We think we have a pretty good idea of what the actual design is. Essentially, the way the plant works is they take natural gas and they burn it in a gas turbine, which is sort of a heavy-duty version. If you look on the wing of a big jet, it's kind of a heavy-duty version of that. That exhaust then goes into another burner set, which has more gas injection in it. There's some water injection that goes in. There's a selective catalytic reduction system to help manage some of the emissions. And then that heat then is used to make steam and drive a secondary turbine. In fact, there's actually 2 generators, and the sum of those 2 things makes up the 435 megawatt. A lot of people talk about gas. Well, gas is very clean, and very clean fuel, and in comparison to coal, that's probably true. But it is still a fossil fuel. It is a big, big burn. The amount of water that we're burning is being used both for management in the burner section, in the selective catalytic reduction, and also to provide the cooling for the plant itself, essentially returning steam back to water to be reused again, is about 1.5 million gallons per day. And to give you an idea, that's the same size well as Lake in the Hills. So this is a big draw, a very local area. Part of the report that we did addresses what the geology actually is under this particular area as we know it. And I think one of the things that is also important to understand is that while in the last 20 years we have a lot of science about how the ground structures and the aquifers work, both the so-called shallow aquifers, which those of you who have residential wells are probably poured into, as well as the deep aquifers, which there are some municipal wells that also pour into that. There's a lot of information about that. We don't know them to a very precise science. And part of the reason is because the only real way that we know them is through what's called well logging. Essentially, the way well logging works is you drill a 9-inch hole in the ground, and as the drill bit bores through the ground, you recover the material that's coming out and you log them. And so the well drillers over the last 100 years have been very good at keeping very good records. And in this area, we have well logs of about 50,000 wells. And from that, we've created these three-dimensional maps. And when I say we, I mean not just my own company, but a lot of work has been done by the county, by local municipalities, by the state geological surveys, the state water survey, as well as the U.S. Geological Survey. And all of that work together has then been used in a variety of different analyses, including people like CMAP. And what those all show is that southeastern McHenry County is particularly vulnerable to overdraw on these aquifers, both the deep and shallow aquifers. And because of that, they are particularly susceptible to contamination. We'll talk about that for a minute. And when we go through I promised Chris that I would not take very long to do this, so I'm going to do this in about 5 or 8 minutes. The first issue is groundwater. This is a chronic impact, meaning that as the well continues to draw, as the plant continues to draw at roughly 1.5 million gallons per day, it will make a larger and larger impact on the area. Some of you have heard the term cone of depression. Essentially what happens is that the strata has a particular resistance through it, and as you draw down on it, the strata cannot feed that well fast enough, and so its level actually drops. In the early 60s, through the early 60s and into just about into the mid-60s, we were drawing so much water in the region out of these aquifers that the level was dropping precipitously. It dropped almost 250 feet, which is very, very significant. In the 70s, there was a big effort to reduce the amount of water that's actually drawn through water conservation efforts. Some of them, many of you were created in a way that was ubiquitous to the community. A lot of it was efficiencies by municipalities, but in addition, we also began drawing more and more lake water. So some of the communities, particularly just east of us, now have lake water. That's reduced the loads on these groundwater aquifers. And those aquifer levels have actually returned. They've returned almost 75 feet, which is very significant. So to now turn around and put another demand on these aquifers not only is damaging to the aquifer, but it's damaging to the entire region because it pushes us back in terms of our goals. In addition to the drawdown, it's important to understand that aquifers, they're not like a big sponge. You cannot dry them out and then simply go re-wet them and then they will recover their capability. Once they've been drawn down, they are damaged forever, and there is no actual recovery. Now, the developer had made a number of claims that says that they want to use gray water, and I use that as quote, to mitigate the amount of groundwater. And obviously, any application where you can reduce the amount of groundwater that you're doing is a valuable thing to take a look at. It's important to understand that there is no infrastructure to pipe water from the municipal outlets from either Cary or Crystal Lake to get to this facility, which is right here. It's a very substantial piping system that would be required. required. You have to understand that if you, municipalities were never designed to deliver this breakwater. What they do is they simply outflow it, mostly to the river. But there's no storage facility, there's no pumping facility, there's no management of the water in terms of real time, particularly since it's going to be used and be ejected back to the atmosphere. One of the problems with gray water is people use this term very loosely. They make it sound as if it's a very sort of innocuous kind of thing. And ultimately, it depends where the source of that gray water actually is. When you talk about gray water, where a lot of this came out of is the work that was done in California. I happen to have been on the California Energy Commission at the time when they worked on this problem. And gray water was originally designed that you would literally have separate plumbing in your house that would collect water from sinks, showers, essentially non-waste collecting facilities. So it didn't come from the toilet. The problem with the gray water that we're talking about here is that this is actually gray water that is being harvested from black water. So this water has already been contaminated with wastewater. There are no mechanisms that we have in place at the municipal level to be able to manage the pathogen issues and a number of the potential carryovers in terms of contaminants. And there have been a couple of experiments around the country that have done that. Mostly this has to do with something called spray irrigation on septic systems. And the communities that have done that have found that they have had significant outbreaks and contamination associated with this. It has not been a good experience. So the use of gray water for this facility is extremely questionable. There's the issue of icing and fogging in the humidity. If you take 1.5 million gallons per day and you spray it up into the atmosphere, particularly in a day like this, you drop the temperature about another 50, 60 degrees. There's no question that you're going to get icing and fogging. And that icing and fogging goes right to road conditions, and it goes to the lake conditions, which we'll talk about in a minute. There's a number of stormwater and aquifer recharge issues associated. This is a 12-acre site. Most of the site will be covered over in one form or another. The real issue here is the potential for stormwater on a 12-acre site to be able to carry over chemicals off-site and wind up in the local recharge. The local aquifers here are very, very prolific. And what that means is that if you take a gallon of water, you drop it on the surface. It takes only a few days, a few weeks, in a few cases a few months, to actually get into the shallow aquifer. And that means that any contaminant that's in stormwater can easily be transferred into the local aquifers. And that's an issue that is completely undiscussed with the application of these actual products. Visual and lighting, we found that we're going to be able to see this plant out to about 3¼ miles. To give you an idea of what that means, is that if you stood on Main Street in Cary, you won't be able to see the plant. And the way we know that is that we did a fairly complex gradient analysis. The easiest way is your big tower out there. It's painted red and white. It's got a big light on it. And you can drive around and see where you can see that light. So if you go over Spring Lake over here, it's going to be very visible. The facility will be about 85% of the height of that tower. So it's a very significant facility. And that's part of the issue associated with the impacts to residential property is the fact that you can see. And this goes also to the issue of lighting. One of the things about McHenry County is that we have a dark background. We have a dark sky at night, unless you're right in Cary or right across the lake. Maybe downtown McHenry, there's not a lot of lighting against the background, and that means that any lighting that is out there is extremely visible. And that will be the problem that you have with this facility. I've seen the artist renderings that the developers put out, that this thing's going to be this sort of very shadowy kind of figure on the night sky. I have spent well over 43 years in power plants. I have never seen a power plant that looks like that. Yeah. They're usually pretty well lit. So there's no question that is going to be an impact. There certainly will be noise impacts. Those noise impacts will extend as much as up to 2 miles. One of the issues with noise is power plants tend to operate in fairly low frequencies. That is, the noise that they generate many times tend to be very low frequency. This is a 60 cycle, 120 cycle kind of frequency. And those things have very long transport paths, particularly in the winter. Because in the winter, you don't have any, all the surfaces are hard and reflective. And so that noise can travel very long distances. So anybody that's within 2 miles, you will be able to hear this thing. You'll be able to go out there and stand up there, and you'll be able to hear it changing power. You'll be able to hear it. There will be periods where they need to do atmospheric steam releases, and you will be able to hear those things. One of the issues we looked at was air quality. When you're burning gas, for every ton of gas, you need 11.5 tons of air to mix with that gas in order to burn it. And that means that you're pushing a lot of gas, a lot of material through the plant. And we have in the report how many metric tons of CO, CO2, how much total carbon is released. This is a big carbon footprint. The easiest way to figure it is if you took 150,000 cars and you drove them for 11,000 miles on that site in 1 year, that's how much emissions that the plant will distribute. Take 150,000 cars, drive around 11,000 miles on site over the course of a year, and that is the equivalent emissions that the plant will deliver. We looked at the issue of odors. These plants do have an issue with odor, and if you look in the literature, it is replete with police reports and situations where they've had to do a natural gas purge. If you've ever been around natural gas, with the captain that they use in the gas so that you can smell it. But there are other odors that come from the plant that have to do with lubricating oil, that have to do with combustion byproducts, and other operations of the plant. One of the issues that many people don't fully appreciate are the radiological issues associated with fossil power plants. Most fossil power plants release more radiation to the environment than nuclear power stations do. And the reason is because in plants like this, where they use water both to help mitigate combustion issues as well as for cooling tower, is that you're pumping it from deep aquifer. And that deep aquifer contains a number of radioactive elements. You're now taking those radioactive elements, which are fine when they're in the ground and shielded, even when they're in the lake and they're shielded, and now you're atomizing those, pumping them from the atmosphere, and now you're inhaling those things. And these radiological nucleides, these radionuclides, when they become inhaled, actually become a fairly serious problem. So there's a fairly significant analysis that needs to be done on what the total radiological release is actually going to be. The company will probably tell you that, we're going to take care of that because we're going to filter out those, which is possible to do. The next problem you have is now you are consolidating those radionuclides on site, and there's the potential to have a local release because the interesting thing with engineered systems is that engineered systems tend to fail. And in particular, a company like this just simply does not have a lot of experience in dealing with radionuclide issues. And so this is an area that has to be looked at in quite significantly. There'll be a lot of construction traffic associated with that. That construction traffic will be heavy lift. So there'll be very substantial impact on the roadways. I know that they've made comments about going to repair some of these roadways. I built whatever 41 times 12 is of miles of roadway. And I can tell you that no matter how much construction permitting you do, and overweight permits you issue, and the whole bit, the total cost of the community always far exceeds what the construction project actually does. The last two issues are accidents and fires. We studied accident and fires in some detail, and we called it out as a separate impact issue. The problem with power stations is they are a very high energy machine. And as long as all these energy streams are going in the right direction and they're all coordinated correctly, that works fine. The problem gets into is when you have an upset. You have a transformer explosion, you have a turbine failure, you have some sort of it can be a very significant issue. And to give you an idea, I used to be the lead electrical engineer up at Zion Nuclear Station. We had a main power transformer explosion. And we collected parts of that transformer over 1.5 miles away. I had pieces about the size of this lectern here brought back to my office, which came out of a parking lot in a grocery store. So anytime that you have one of these facilities, you have to recognize what its impact is going to be in the engineering field. It's called nominal condition, if there's an explosion or fire. And the last issue I just want to touch on is this issue of zoning creep. And this is really a combination both of engineering and municipal issue. It's very common in a lot of municipalities and counties that for one particular interest, we want to be able to give some sort of zoning variance. In this case, they need to change zoning. They also need a special use permit associated with this. The problem with that is that has long-term impacts on the health of the community. From the perspective of, if you give this person a zoning variance associated with this plan, or the landowner is, lives right next door, says, oh, you know, I would like the same thing. And what happens is this tends to cascade down. There's actually a whole legal issue associated with it, which Stephen is much better prepared to speak on this than I am. But the issue has to do with the South Act. Anybody that's been a mayor understands the problem associated with this. So the zoning creep issue ultimately leads to industrialization, because that's where it all goes. It goes down to industrialization and identification. So with that, those were the basic issues that we found. Bottom line is this is not a good site for this facility. There are a lot better sites associated with it, and there's no question that this site, this project presents quite significant impacts to the community. Thank you very much. When people talk about this issue, they do not reference the CO2 emission. They have a particular the question was that the developer indicated that they were going to have 25 metric tons per year. 25 metric tons per year of volatile organic compound emissions. And the problem with doing this is that they do not account for the, the problem is that they do not account for the total CO2 emission. They also don't, those numbers that they give are also at, the number that they give is also at power. And the unit is expected to release 782,156 metric ton of CO2 per year. And that's recognizing that you're doing, roughly speaking, about 360 grams of CO2 per kilowatt hour. So if you want to get a little serious with the numbers, we can go through that. But there's no question that this is a big impact. And there's now a lot of study about what's called these CO2 domes. What happens if you have a facility like this, it's generating 750,000 tons of CO2 a year, and that of course changes the local CO2 concentration. And so the question is, what are the health effects associated with those things? And it's not just because of power plants. This also happens in municipalities where you have very high traffic densities. The question was, how long should we expect the plant to live and or to operate, what its useful life is, and whether or not natural gas will continue to be a long-term viable fuel for making electricity. It's an excellent question. We do cover this in the report. These plants historically do not have a particularly long lifetime. So the subject that says, well, you know, these guys are going to be paying taxes, the facility in Manuka is already no longer paying taxes. It's less than a decade old. And the reason has to do with, those of you who are accountants here will know this, that the power industry has been very good about getting a very powerful depreciation table on their assets. And so what happens is that all this equipment depreciates down to zero very, very rapidly. And because of the way tax asset base works, you wind up not doing that. So unless the village is able to establish an ad valorem tax, which is, where's our state representatives here, they need to probably work on that, then you're going to wind up with no tax capability. These plants, because of the variability in the marketplace, generally do not last longer than 20 years. You won't find one of these plants that's older than 20 years. And the typical strategy is to abandon it for this.
We have 3 hands raised, so we are going to, once people leave, and people like families, let's try to go ahead and do that. The question was if any of us have any knowledge of the alternate sites of the power plant. Do not.
My question is, will the radionucleotides be stored in liquid fashion? If the radioactive
the question was, if they strip the groundwater in order to clean it of radionuclides, how do they actually store these radionuclides? And that's one of the issues today. It's a very significant problem. And it's how these radionuclides are effectively bound up. The best way to do it, of course, is to chemically bind them into solids so that they are not easily transported. Unfortunately, that's not usually how they do. They're usually collected in resin beds, and so they do tend to continue to be, there is the potential for migration if there's a release. And normally, that's not a problem. Where, you know, if you have a big full-time dam facility and they got 300 people working there, that's usually not a problem. It's where you have a facility, particular a company like this that does not have radionuclide experience, that's usually where they get in trouble.
And will there be mercury emitted from these smokestacks?
Yeah.
Mercury part?
Yeah, there will be some mercury components. We are unable at the moment to quantify that until we get more detail from the developer on the specifics of some of the components.
Yeah, the revolution starts now in your own backyard, in your own hometown. So what you do is standing around, just follow your heart. Your revolution starts now. Yeah, the revolution starts